Imagine a power source that produces zero greenhouse gases and is physically incapable of a catastrophic meltdown. And instead of drilling for oil or mining coal, this theoretical power source runs entirely on water, the single most abundant element in the known universe. That process is nuclear fusion, the exact same atomic reaction that naturally powers the sun and every star in the night sky. It works by taking two incredibly light atomic nuclei and forcing them to merge together into a single, heavier nucleus. If this flawlessly clean, high-yield reaction naturally illuminates the entire universe, our long-term survival relies on figuring out how to replicate it right here on Earth. But this utopian energy has absolutely nothing to do with the technology currently operating inside modern commercial nuclear power plants. Those facilities rely on nuclear fission. Nuclear fission is the process of taking heavy, highly unstable atoms, like uranium, and violently splitting them apart. While splitting the atom generates a massive amount of usable power, the reaction relies entirely on radioactive decay and leaves behind toxic waste that lasts for millennia. By contrast, merging tiny hydrogen atoms together creates vastly more energy, and its only physical byproduct is a small amount of completely harmless helium gas. We know this reaction is infinitely cleaner and more powerful. The reason it doesn't power your home right now is because building a working star on Earth presents us with the most difficult engineering paradox in human history. To force those atomic nuclei to actually merge against their natural electromagnetic repulsion, we have to recreate the extreme thermal conditions found deep inside a stellar core. Specifically, hydrogen gas must be superheated to 150 million degrees Celsius. That is 10 times hotter than the center of the sun. When gas gets that hot, it becomes plasma. Plasma is the fourth state of matter, a threshold where extreme temperatures cause a substance to radically change its physical behavior. The intense heat causes atoms to vibrate so violently they snap apart, breaking down into a churning, chaotic soup of individual, free-floating electrical charges. This is where we hit the absolute physical wall. There is no solid material on the planet that can hold 150 million degree plasma. Any physical container you try to put it in will instantly vaporize. If a solid steel box will instantly melt the moment it touches a star, physicists realized they had to invent a box made entirely out of nothing. Their solution is the Tokamak. A Tokamak is a massive, donut-shaped machine designed specifically to house an artificial star. The outside of this incredibly complex vacuum chamber is heavily wrapped in some of the most powerful electromagnets ever constructed by humanity. Because that superheated plasma is essentially a soup of raw electrical charges, its particles are forced to react to those external magnetic fields. When the ignition sequence begins, the hydrogen fuel is heated into a violently twisting ring of 150 million degree plasma. This technique is called magnetic confinement. Magnetic confinement is the process of generating an invisible, crushing force field that pushes the superheated plasma inward, suspending it in midair. By mastering this invisible magnetic architecture, scientists solved the impossible hurdle of containing a star without a single drop ever touching the walls. Achieving this requires a staggering global engineering effort, with massive fusion facilities currently under construction around the world. At this stage, the hurdle is no longer about whether we can create a fusion reaction. It's about overcoming the massive energy deficit required to power those gigantic electromagnets. This line graph tracks our progress, showing the relationship between input energy and output energy. The intersection point right here is ignition. Ignition is the precise mathematical threshold where the reaction produces more energy than it consumes to keep running. Right now, thousands of researchers across various competing global facilities are agonizingly close to crossing that specific threshold. Once ignition is permanently achieved and the plasma burn is sustained, these machines will finally operate as true net-positive power plants. Crossing that line will transition human civilization away from energy scarcity, unlocking a clean, limitless power supply that can sustain us for millions of years.